So in this question, we have limit as h tends to 0 e raised to root x plus h minus root x minus 1 upon h into same power we have taken root x plus h minus root x into root x plus h minus.
Ma'am, video is not running properly.
Yes.
Ma'am, video is not running properly.
Abhijit sir, am I audible, visible, clear? Is it clear?
Ma'am, you're audible but visible. Your video is little bit paused sometimes.
Okay. Now.
Yes, ma'am. That's
Might
what I'm
be-
saying.
Now it is okay.
Now okay, but again slowly it is paused. Video only. Audio is good, but video.
Okay.
Yes, sir.
Okay. So here we have now, if we take this h to this side, means in one bracket we have root x plus h minus root x upon h, and in another bracket e raised to root x plus h minus root x minus 1, whole thing divided by the same power root x plus h minus root x. Now students, we have seen the algebra of limits. Here product of two function is there. We can apply limit to both the functions. So in one bracket you will get the standard form, that is e raised to x limit as x tends to 0 e raised to root x plus h minus root x minus 1, whole thing divided by root x plus h minus root x. In another bracket, limit as x tends to 0 root x plus h minus root x, whole thing divided by h. Now students, if I'm visible, please, what is the limiting value of e raised to bracket minus 1 upon same bracket? Here the standard form we are getting. So for this standard form, the limiting value is 1. So we have e raised to x into 1 into limit as h tends to 0 root x plus h minus root x upon h. Now student, here if we'll put h equals to 0, so we'll get what we are getting, denominator 0 we are getting, so we cannot apply the limit here, so we have to rationalize the term. So it is, when we will rationalize this, so what will be the numerator? It will be, see, we'll evaluate this limit as h tends to 0 root x plus h minus root x upon h. Equation number 1 will take. Now for evaluating this limit as h tends to 0 limit as h tends to 0 root x plus h minus root x upon h.
Ma'am, video is not proper.
See, we are rationalizing. Now need root x plus h minus root x upon h. So what is the rationalizing factor? Root minus root, it is there. You can,
Ma'am, root x plus h plus root x upon h.
Very good, very good. Root x plus h plus root x. So we'll multiply and divide by root x plus h plus root x upon root x plus h plus root x. Now a minus b into a plus b. So we have a square minus b square. Here our a is root x plus h. So its square will be x plus h only. Is it clear? Is it clear? Yes, boys. Navneet?
Yes, ma'am.
Okay. So what will be the numerator? Limit as x tends to 0, x plus h minus h, whole thing divided by h in bracket square root of x plus h plus root x. Now student, x minus x will be 0 and plus h, only h is there in the numerator and denominator, so we can cancel it. So what will be there in the denominator? Limit as h tending to 0 1 upon root x plus h plus root x. Now student, here h is tending to 0. So if we'll put h 0 in the denominator, we are getting root x plus root x only. What is root x plus root x? What is root x plus root x?
2 root x.
2 root x. So The limiting value will be 1 upon 2 root x. Now in equation number 1, if we'll take, so what we are getting, d by dx of e raised to x is e raised to x into 1 into 1 upon 2 root x. So this is equals to e raised to x upon 2 root x. Getting? Yes, students. So in this way, we have found the derivative of the function e raised to root x by using the first principle. Okay. Now, if we have the function x into e raised to x into e raised to x. Now, how we can differentiate it by using the first principle? Yash, Navneet,
Yes, ma'am.
Shivaji Raut, Atharva,
Yes, ma'am.
all are there, no? How we
Yes, ma'am.
differentiate
Yes, ma'am.
x into e raised to x? How we can differentiate x into e raised to x?
Ma'am, by product rule.
By product rule. Yes, you find the differentiation, and by using first principle, I am solving on the board. Am I visible?
Ma'am, video is not running properly. Ma'am, अटक जाता है ma'am बीच में.
अच्छा, ठीक है ठीक है. लेकिन मैं जो बोल रही हूँ वो समझ रहा है ना?
Yes, ma'am.
Okay. So by using first principle, we'll find the derivative of x into e raised to x. So it is f of x equals into e raised to x. So f of x plus h will be e raised to x plus h. Getting? Now here we'll simplify the term f of x plus h minus f of x. Means f of x plus h minus f of x. So here it will be x plus, here also we can multiply that x into e raised to x plus h plus h into e raised to x plus h minus x e raised to x. So from we take x e raised to x common, will be x e raised to x common in bracket e raised to h minus 1 is there. So here, and in the denominator we need h, and in the first principle denominator is x, term e is minus 1. Okay, so now we'll write the derivative of x into e raised to x. So here d by dx, is it visible? Okay, d by dx of h is to 0, f of x plus h of x. Expression 1 will put here limit as h tends to 0, x is everything divided by h. Okay, now we will separate both the terms. Is it clear? No, is that yes? Neeraj sir?
Yes, ma'am. You are audible as well as visible.
Okay, okay. Thank you. So here we have, we'll separate this h with both the terms. So here limit as h tends to 0, x e raised to x e raised to h minus 1 whole thing divided by h, plus if we separate this h and h will get cancelled. So we have e raised to x plus h only. Now if we apply the limit here, this x into e raised to x term is not containing h. So here we can take this out. So it will be limit as h tends to 0, e raised to h minus 1 is the standard form. The limiting value is 1 for this. And then if we'll put here x0, we are getting e raised to x. So here we'll apply the limit. Limit x e raised to x into limit as x tends to 0, e raised to h minus 1 upon h plus so e raised to h. So this limiting value will be 1, x e raised to x into 1 plus here e raised to x plus 0 will be e raised to x. This is the derivative of x into e raised to by using product rule. No one is there, I think. Yash, Navneet.
Yes, ma'am.
Navneet, have you solved by using product rule?
Yes, ma'am.
What is your answer now?
Ma'am, e raised to power x bracket में x plus 1.
Same you are getting. So by using
Yes, ma'am.
first principle and by using product rule also, same answer
Yes, ma'am.
we are getting. Okay. So now this question for 6 marks it can come. For formula you will get 1 mark. For putting the f of x plus h value and fx value will get half mark. Like that stepwise marks you will get. Okay. So
Yes, ma'am.
any doubt is there in this question?
No, ma'am.
Boys, for 10 seconds switch on your videos. Switch on your videos. That Atharva is there. Why are not replying Atharva then? If you are there.
Ma'am, we are not allowed to switch our videos, ma'am, by the host.
Okay, okay. Okay, Yash, Atharva is there. Switch off your videos, Yash and Atharva. Arya and Mayank. Arya, Mayank. Bharat ma'am, both are absent. Huh? They have not joined the audios. Shivaji Raut.
Okay.
Shivaji Raut.
Yes, ma'am.
Okay. Ajinkya is not there. No? Abhijit Chattar.
Yes, ma'am.
Okay. Is there any doubt in this question? Is there
No,
any
ma'am.
doubt? Okay. So we'll take one more question, which is differentiate log of sin x by first principle.
Ma'am, cortex.
Yes, beta.
Ma'am, is cortex is the answer?
For this question, now? Yes, yes.
Yes.
But by using first principle also we have to solve it. Directly for 4
Yes,
marks,
ma'am.
6 marks, you cannot write the answer. They will not give you half marks also. Half mark also.
Yes, ma'am.
Okay. So
Yes, ma'am.
differentiate log of sin x by first principle. Okay, so here f of x is log of f of x is log of sin x plus h. Get it? So what is the derivative then? D by dx of log of sin x is limit as h tends to 0 f of x plus h. So directly you can put log of sin of x plus h sin of x divided by h. Any doubt in this step? Any doubt, student?
No, ma'am.
Okay. So here we know that in logarithm, if log b minus log a to the base same, if same base is there, it will be by a log b minus log a. We can write log of b upon a.
Yes, ma'am.
Okay. So we have now this limit as h tends to 0, 1 upon h in getting any doubt in this?
No, ma'am.
Okay. Now, student, in limits we have the standard form. If log of 1 plus x is there, getting log of 1 plus x bracket raised to 1 upon x means whatever. Here I will write 1 plus x raised to 1 upon x, or this power can be in the multiplication of log also, because we can take whatever the multiplier is there, the power we can take for this. So here, if this is there, we are getting the as x tends to 0, log of 1 plus x raised to 1 upon x. The power. Now, student, here log of this quantity only, rational function is plus by minus, so that we get the standard form. So here we have log of 1 plus sin of x plus x upon sin x minus 1. Okay, so what is plus h upon sin x minus 1. Minus sin x upon sin x means it will be limit as x tends to 0, 1 upon h upon sin x. Okay. Any doubt to this step? Yes, student. Any doubt?
No, ma'am.
Okay. So now what we will do? See, whatever the term is there with log of 1 plus, it will be there in the power, or we can take that power as a multiplier. Here, upon sin x. So here we have to multiply and divide it by sin x plus sin. So that we are getting C. I erase this. So we have to multiply it now. So equals to limit as h tends to 0, 1 upon sin x upon sin of x minus sin of 1 plus sin of x plus h upon x. So we will divide also. So here what we are getting this here it will be 1 bracket in that minus sin upon x. So sorry, here I have written x. Okay, now into now x plus sin whole thing divided by sin x, and its reciprocal is there in the power of the bracket on now for this the limiting value, if is both the brackets, so we are getting this limiting value as a 1. Now student, So here this value will be 1. So we have now limit as sin of plus now what sin A minus sin B? Sin A minus sin B, S minus S. Navneet, Atharva,
Yes, ma'am.
what is sin A minus sin B? Sin minus sin.
Ma'am, sin A plus B by 2 into cos A minus B by 2.
No. Not that form. That we have seen a sin A plus sin B, sin A minus sin B, like 2SC, 2CS, in that form. The terms will cancel, that only we use here. And those are present for they only will present. I will consider them only. Remaining students I will not consider. Yes. Sin A minus sin B. Of A plus B by 2 into sin of what? A minus B by 2. Is it clear? Navneet, because if you don't know this form, how you will solve this now?
Yes, ma'am.
So we have here sin minus sin. It will be limit as x tends to 0 to cos of x plus h plus x by 2. So it will be cos of x plus h by 2 minus x by 2. So sin of h by 2 upon x. Now student, here 2 upon h is there. Can we write here h by 2? Because denominator is numerator. So can we write the numerator as the denominator's denominator? So it will be h by 2 for this. And if we apply the limit here, we'll get this limiting value 1. If we'll put we are getting. What is cos x upon sin x? It is cot
Yes,
x.
ma'am.
It is cot x.
Ma'am,
Yes.
मैम वो h by 2 नहीं समझा मैम नीचे जो की है.
हाँ, अरे यहाँ पे देखो डिनोमिनेटर में h था ना.
Yes, ma'am.
तो वो एज इट इज लिखा मैंने यहाँ पे h बराबर.
Yes, ma'am.
हाँ, तो और ये जो 2 था यहाँ पे वो न्यूमरेटर में है.
Yes, ma'am.
हाँ, so can I write 1 upon b equals to b?
Yes, ma'am.
Okay, so numerator can I write the denominator's denominator?
Yes, ma'am. समझ गया मैम.
Okay, so here this limiting value will be 1. This will be cos x and upon sin x. So what is the limiting value then? Cos x by sin x. Differentiating log of sin x, we have differentiation cot x. Any doubt in this?
No, ma'am.
Any doubt, student?
No, ma'am.
Okay. Thank you.